Hi, this experiment is about voltage and current dividers. So consider a voltage source, which is your power supply, and let's say we have two resistors, R1 and R2. If the goal is to find out the voltage across R2, which I'm going to call it V2, and let's say this is V input, this is a voltage divider circuit, so V2 is going to be calculated based on this formula. Please notice that for voltage, in the numerator, the related resistor should be considered. So I'm measuring the voltage across resistor R2, so in the denominator you also see R2. As for current divider, let's consider a current source I of input, and let's consider two resistors in parallel, so let's call them R1 and R2. This is going to be I1 and this is going to be I2, and I2 is calculated based on In. For current divider is opposite of voltage divider. The other resistor in the other branch is going to be in the denominator. So I was measuring I2, while in the denominator it's R1, which is the other resistor in the other branch. So make sure you always consider the right resistor in the denominator, and in the denominator is always the addition of two resistors. So these simple formulas are used to calculate the current and voltage, and in this experiment that's what we are going to do. The multimeter is going to use to directly be connected to R2. So if you want to measure this, just consider a digital multimeter here, DMM, and if you want to measure the current here, the tricky point is that you cannot connect a current meter, as we mentioned in previous experiment, in parallel. You have to cut the link from here. So let's say we cut the link from here. In this case, our new circuit will be like this. So these are the 2 points that I have cut from the circuit, and here I'm going to put my digital multimeter in a current mode. So in this case, the current that is passing through R2, which is going to be I2, this current is also passing through the multimeter, which is a current meter in this case, and the digital multimeter is going to measure the current. One of the common mistakes that I have seen from a student in the lab is that they do not put the current meter in series, and as a result they are not going to get the correct current measurement. Another thing is part of the lab is asking to connect a load resistor. I wanted to make sure that the student recognize that the load is going to be inserted here. So this is going to be R load in parallel with R2, and then you have to change the load resistor based on the table, at each point you're measuring the V2 or VL. They are the same, so please notice that V2 and VL are the same in this circuit. And then part of the table is asking you to calculate, to measure the load voltage and calculate the voltage gain. So voltage gain in this case is going to be VL over Vin. So you measure this voltage, and whatever you read here, you divide it by Vin, and that would be your voltage gain. And the same for the voltage gain. If you want to measure the voltage gain here for R2, the voltage, the current gain for I2, here I'm going just to write down the current gain is, in this case, I2 over In. So you measure the current here, and this is your In divided together. That's going to give you the current gain. Next part of the lab is about the Wheatstone bridge. So Wheatstone bridge is used to measure an unknown resistor. So consider that you have a resistor here. Let's call this resistor Rx. So a resistor that we do not know the value for any reason, and we want to accurately measure this resistor. So first we have to create a Wheatstone bridge, and then we have to balance the bridge. So consider R1, R2 and R3 to be the accurate known resistors, and then consider 2 point A here and point B here, and then let's say I'm going to put a current meter here, and let's say the resistor R3 could be a variable resistor. We call it a potentiometer, or abbreviated as POT. So the potentiometer is a variable resistor, and I'm going to show you in one of the slides in this video the way that a potentiometer is looking like. And let's say the R3 is going to be changed again using a potentiometer. So what we do, we connect this to a power source, the voltage source. Let's consider that a voltage V is connected here, and then we start changing the R3 up and down until the current meter is reading almost zero current here. The closer this current is to the zero, the more accurate is the value of Rx. When the current is zero, it means there is no current flowing from point A to point B. In this case, we just say that the bridge is balanced. And when the bridge is balanced, a formula exists that says R2 times R3. So basically the cross resistor, the resistors which are across each other, is equal R1 times Rx. That happens when the bridge is balanced. Again, the meaning of balance means that there is no current flowing from point A to point B. And from this formula, we can calculate Rx, which is R2, R3 divided by R1. So if R2, R3 and R1 are accurate resistors, then Rx is going to be accurately calculated from this formula. So in the experiment, in the Wheatstone bridge experiment, you need to use a potentiometer. Next part of the video is going to show you how to implement the potentiometer on a breadboard, how to insert it on a breadboard, and how to balance the Wheatstone bridge. This is the implementation of Wheatstone bridge that I have done on XK150 advanced breadboard, which you can see in this video. This advanced breadboard is including a breadboard which is similar to any other breadboard. We have the option to use either the 1K ohm potentiometer or the 100K ohm potentiometer. On this XK150 board, we're going to use the 100K ohm one. Why? Because it's giving us more flexibility to cover any resistor from 0 ohm to 100K ohm. So we better to connect it to this potentiometer. And as you can see, our bridge is including 4 resistors. So 1, 2, 3, and the 4th one is the variable resistor, which is connected through the black wires to our potentiometer. So what I have done, I have used the top row because this row is connected together, so these 2 ends are connected together, and as well as the same here, these 2 ends are connecting together. Make sure they are in the same connected column, so these 2 resistors are connected at this point. These 2 resistors are connected at this point, so make sure in the same connected column as well. So the black wire is in the same column as this end of resistor is. To use the potentiometer, we need 2 wires. These 2 wires are going to hole number 1 and number 2, so you have to insert the wire inside the holes. Each potentiometer has 3 pins. That's why you see pin number 1, 2, 3 on the video. And if I tap from number 1 and number 2, which is the variable one, so you can see the arrow here. So this means that pin number 2 is the variable pin. Pin number 1 and pin number 3 are the fixed one. So we need to only tap from one of the fixed holes, which is number 1 in this case, and pin number 2, which is the variable one. So I connected them through the wires, the black wires. And if I turn the knob here, so if I go all the way to this end, it's going to be 0 ohm. If I go all the way to this end, it's going to give me the 100 kilo ohm resistor. So now I need to power the board, the bridge. So in order to power the bridge, what I did, I am using the 6 volt like connector. As you can see, it is set to 5 volts, so it's set to 5 volts. So I have 2 pins here. So I'm going to connect these 2 pins to my bridge. So it's going on the top, and then this is going to the bottom. So the bridge is powered now. Now in order to balance the bridge, I have to measure the voltage at this 2 point. So this 2 point, I have to measure the voltage. So what I have done, I have connected a probe to my voltmeter. Make sure it's connected to the volt input. Make sure the DC volt is used. So millivolt DC is what you see on the top. So I'm going to connect this point, this probe here, and this probe to the other end, because I need to measure the voltage between these 2 points. So let me just measure this point. And now I have to play with this knob. So I'm going to keep rotating this knob, and when I do that, I'm going to see the voltage on the voltmeter. Right now it's showing minus 98 millivolt. So I'm gonna go, I'm playing with the knob now, so I'm keep returning the knob, turning the knob, and you can see it's going to plus. All of a sudden it became 1.9 volts. So we were on the negative side and we are now on the positive side. So it means that if it eventually passed the 0 volt, so our goal is again to go back and go slowly till we get 0 volt in there. So 1.170 millivolts, 6. We are in a very low range, close to 0. We have to go even more slowly. I'm almost at 0. Okay, I passed from plus to negative and is showing 3 zeros on the before the decimal point. So this is like the 0 volt for me. The rest is pretty much noise, what I'm seeing. At this point I have to go back to the bridge, and sorry, I have to turn the power off. So we turn the power off here. I'm disactivating, so it shows output off. And what I do, I remove these 2 wires here. So these 2 wires are removed from this point, and I have to measure the resistor between these 2. So in order to do that, what I do, I connect this to this resistor, and I connect this to here. So this is the this is the probe from the multimeter. So now the voltage, I have to click on ohm, and it's showing 9.1 kilo ohm. So it means that the variable resistor was 9.1 kilo ohm. So in this case the bridge was balanced, and the required resistor to balance the bridge was 9.1 kilo ohm. So you have to do pretty much the same thing for your experiment to balance the bridge and to measure the resistors. Thank you very much for watching this video, and good luck.